Hello, how are you everyone? Our lesson today talking about tangent lines. Understanding the tangent lines. Let's explain the tangents. What does it mean? Tangent to a circle is a line that intersects the circle in exactly one point. By looking at the line AB is intersected the circle at exactly one point. Point P, the end point of the radius OP. This is the meaning of tangent of a circle. And this point P is called point of tangency. Okay. If a line is tangent to a circle, this is theorem 12.1. If we have a line is tangent to a circle, like line AB is tangent to our circle, then this line is perpendicular to the radius at the point of tangency, point P. Then this line, if AB is a line perpendicular, if AB is a line tangent to this circle, then this line is perpendicular to the radius OP at the point P. Then we have right angle as you see here. Then angle APO is a right angle at P. How to find the measure of some angles? For example, if we have ML and MN are tangent to the circle O, what is the value of X? Here, as you know, we have quadrilateral LONM. This is quadrilateral. Since LM and MN tangent to the circle O, then they are perpendicular to the two radii OL and ON. Then ON is perpendicular to this tangent as you see here, and also since ML is tangent to the circle is also perpendicular to the radius OL, then we have three given angles. Angle OLM is 90 degree, angle ONM is also 90 degree, and the given angle, the central angle, 117. Then we can find the measure of angle X by subtracting the given angles from the interior angles of the quadrilateral, which is 360. Then to find the measure of angle X, we will subtract the sum of the given angles, 90 plus 117, minus the sum of the interior angles of the quadrilateral, 360. We will get that measure of angle X equal 63. The same idea in the second question. If ED is tangent to the circle O, how to find the measure of angle X? Since we have given angle 38, and since ED is tangent to the circle, then ED is perpendicular to the radius OD at the point D. Then we have right angle. ODE is also right angle. Since we have given two given angles, right angle 90 degree and this angle 38, we can find the third angle of the triangle by subtracting their sum from 180 to get that measure of angle X equal 52. How to find the radius of the circle? What is the radius of the circle C? If we know that the given side length AB is 12 and this side, not all the side 8 here, not CA, not length of CA, this part only until the circle, this is 8, and the radius here, this is X, and the other radius CB is also X. Then we can apply the Pythagorean theorem as we studied before, that the Pythagorean theorem says that in right triangle the hypotenuse squared equal the sum of squared of the other two legs. Then by applying this theorem we will get that AC squared, the hypotenuse, equal the sum of the squared of the other two legs, AB squared plus BC squared. By making a substitution, instead of AC, we will put that length x plus 8, and instead of AB, we will put 12, and BC, we will put x. After that, we will make after making a substitution, we will evaluate the exponents. Here, this bracket, if you remember how to evaluate this monomial squared, we said to evaluate the monomial squared, we will find this x squared, the first squared, plus first by second by 2 plus the second squared. Then the first squared is x squared, the second squared 64, and in the middle, first by second by 2, you will get 16x. The right hand side, 12 squared is 144 plus x squared. To solve this equation, we will cross x squared in both sides, then we have 16x plus 64 equal 144. By moving 64 to the other side in opposite operation, in the inverse operation, 144 minus 64 is 80. Then 16x equal 80, then x equal, by dividing 80 by 16, we will get that x equal 5. By the same idea, what is the radius of this circle O? Here, by applying the same theorem, Pythagorean theorem, we will get that this radius 6 plus x squared equal the sum of squared of the other two sides, 10 squared plus x squared. By evaluating this monomial squared, as we said, the first squared, the second squared, first by second by 2, we will get x squared plus 12x plus 36 equal 10 squared is 100 plus x squared. And also by crossing both of x squared in both sides, right hand side and left hand side, like that, then we will get 12x plus 36 equal 100. By moving 36 to the other side in subtraction, then we will get 12x equals 64, and by making a division, then x equals 64 divide 12 equal 5 and 1 over 3. What about the converse of our theorem? We said our theorem, if a line is tangent to the circle, then this line is perpendicular to the radius. But our converse here, the same idea, but we will make it in the converse idea. If a line is perpendicular, if we found that AB, this line is perpendicular to the circle, then this line is also is tangent to the circle. Again, if a line AB is perpendicular to the radius at its end point P, then this line is tangent to the circle. Let's apply this idea here. Here the question is ML, here this ML tangent to the circle? To prove that, then we need to apply our Pythagorean theorem. If we found that the hypotenuse, this hypotenuse MN, if it was its squared equal the sum of the squared of the other two legs, if we found that, then this is tangent to the circle, because we will find that is perpendicular to the radius. From here we will prove this is tangent. At the first, let's apply Pythagorean theorem. We know that if we found the hypotenuse mn squared equal the sum of the squared of the other two legs ml squared plus nl squared, if it's happened, then this is right triangle at the point L, then this ML perpendicular, then this ML is tangent. Let's apply that and let's check if this is true or not. Mn squared 25 squared equal 7 squared plus 24 squared. Let's calculate that. If we found the two sides equal, then this is the right triangle at the point L, then ML is tangent. Yeah, we found that both of the two sides are equal. 625 equals 625 after calculating both of them. Then here we have right triangle, right angle at the angle L. That means ML is perpendicular to this radius. That means according to the converse of the theorem, if this is perpendicular to the radius, then this line, this segment ML is tangent to the circle N. The other question, use the diagram above. If NL equal 4, ML equal 7, and NM equal 8, then the line segment ML is a tangent. Is ML is a tangent? To prove that ML is a tangent, we will apply the same idea. Here, let's apply the Pythagorean theorem. Mn squared, let's make substitution. 8 squared equal 7 squared plus 4 squared. 8 squared, as we know, 64 equal 7 squared 49 plus 16. We will get that 64 the left hand side, but the right hand side 65, they are not equal. Then ML, since ML not perpendicular to the radius NL, then this line segment not tangent according to the converse of our theorem. Let's apply this theorem. Here we have another theorem. If two tangent segments, two circle, they share common end point outside the circle, then the two segments are congruent. If the line segment AB and the line segment CB, if both of them sharing, if the two tangents here sharing the common point, the same end point like AB and BC, then both of them are congruent. Let's solve this question according to our theorem. What is the perimeter of the triangle ABC? Here, as you see, since AD and AF they sharing the same common endpoint A, and the other two segments DB and BE, they sharing the same common endpoint, the same as CF and CE. Then the segment here, segments tangent to circle from a point outside the circle, they are congruent. Then we will get that AD equal AF equal 10 centimeter, and also BD equal BE equal 15 centimeters, and CF equal CE equal 8 centimeters. Then we can find the perimeter of this triangle by adding the segments 10 plus 10 plus 15 plus 15 plus 8 plus 8, then the perimeter equal 66 centimeter. Let's solve the next question. If the perimeter of the triangle PQR is 88, here we have given perimeter. What is the length of QY? Since QY and QX, both of the two segments, the tangents here with the common end point Q, then QX equal QY. Let's write the equation. By adding this PX 15 and PZ also 15, then 15 plus 15, and as we know that RZ equal RY, both of them 17, then plus 17 plus 17, plus the other two segments, the unknown segments QX plus QY. Since QX equal QY, we can make substitution, then QY plus QY, because both of them the same length. All of that equal the given perimeter 88. By calculating the given length, then 30 plus 34 equals 64 plus QY equal 88. Then QY plus QY, as you know, 2QY, and by moving 64 to the other side, we will get that 2QY equal 24. Then by dividing by 2, we will get qy equal 12. This length qy the same as qx also equal 12. How to find x? We have quadrilateral ACOD. This is quadrilateral, 4 sides, and we have given angles. This AC is tangent, then we have right angle here perpendicular to the radius OC. We have right angle, and we have given the central angle 117, and also as we see here in the given AD is also tangent to the circle. Then this angle also is right angle, is perpendicular to the radius OD. Then we have 3 given angles, 90, 117, 90. We can find the 4th angle of our quadrilateral by subtracting their sum from 360. Like that, we will get that measure of angle x equal 63. Let's solve another example. Find the value of x. Find the length of AC, because all of that is x. Here, since CB is tangent, then perpendicular to AB, then this angle is 90 degree. Then we have right triangle at angle B. Then AC here, this is hypotenuse. Hypotenuse squared equal the sum of squared of the other 2 legs. AC squared equal BC squared plus AB squared. That means AC squared, by making a substitution, AC squared equal 64, 8 squared plus 25, 5 squared. Then AC squared equal 89. Then AC, by finding the square root of 89, we will get AC equal about 9.4. Thank you for listening and have a nice day.